All right, so we are going to apply the thermodynamic and kinetic products in butadiene system. Okay, so we're doing a hydro bromination on butadiene. The energy diagram of this reaction looks like this. Here we go. All right, first question, if you look at this reaction, the first step doesn't really matter. So both pathways have the same first step. Okay, once it forms the carbocation, so it's split into two pathways. Now the question is, which product is kinetic product? 1,2 adduct or 1,4 adduct? Well, we have the speed. We look at the activation energy, right? And you can see that the transition state of 1,2 adduct is more stable, so lower activation energy. So 1,2 adduct is kinetic product. Okay, and the reason why the 1,2 adduct is kinetic product. So people propose that this happened. So if you look at the reaction mechanism, so take double bond on the right side with protonation, all right, and bromine breaks off. Now the bromide that breaks off now hang around closer to carbon 2. Is it 1, 2, 3, and 4? Carbon 2 is right here. Then carbon 4. Right, so the reaction between bromide and carbon 2 is faster than carbon 4, and that's the reason why 1,2 adduct is kinetic product. Okay, now one more. So 1,4 adduct or 1,2 adduct, which one is more stable, and why? Well, you can see 1,4 adduct is more stable, so lower in activation, lower in potential energy. But why though? If you remember the double bond, right? We have mono substitute double bond and a di substitute double bond. So the disub is more stable than the monosub, right? So the more substitute alkene, the more stable alkene. So that's thermodynamic product. Okay. All right. So there are two pathways. One is lead you to kinetic product. The other one leads you to thermodynamic product. Now the question is, how do we selectively make kinetic products or thermodynamic products? Okay. I'm going to add just kind of new keyword, but I mean it's the same thing. So we use kinetic control. These are the reaction conditions that favor the kinetic products. Okay. All right. So how do we make a kinetic product favor? Well, two ways to do it: low temperature and short reaction time. Start with a short reaction time. If you remember this diagram, so the kinetic product is produced faster at the beginning and then get converted back to the thermodynamic product. So we don't get a lot of kinetic products at the end. If you want your reaction to produce just the kinetic products, I mean favor the kinetic products, what do you have to do? Well, we're gonna stop reaction right there, just right at that point. Don't let it convert it back to the thermodynamic product. All right. So basically, if you run this reaction, you get two pathway. One go to 1,2 adduct, the other one go to 1,4 adduct. All right. So we're gonna stop reaction time. So do it. Run the reaction with short reaction time before the 1,2 adduct get converted back to the carbocation, and then bromide attack, you get 1,4 adduct. All right. So number one, if you want a kinetic product, so short reaction time. Okay. All right. Number two, low temperature. Now look at right here. So if the 1,2 adduct that has been formed at the beginning, if the 1,2 adduct were to get converted back to 1,4 adduct, this process need to happen. Are you ready? 1, 2, 3, 4. So bromide leaves, loss of leaving group, go back to the carbocation, and then carbocation go further to 1,4 adduct. The going backward right here, look at the activation energy right here. So 1,4 adduct right here. If you're going backward, so the molecule has to overcome that much activation energy, right? So basically, if you don't want this compound to go back to carbocation, we keep the temperature low, so it won't overcome that activation energy. That's why we use low temperature. Okay. So my point is, if you want to make kinetic products, we use kinetic control, and kinetic controls low temperature and short reaction time. Okay, so you're at 0 degrees. For the reaction time is a relative. Some reaction time for kinetic controls that could be 1 second, could be 10 seconds, could be hours, could be years. It just depends. So I would never put the reaction time on it, right? But we're gonna focus more on a temperature. All right, kinetic products. So use kinetic control. Thermodynamic product, we use thermodynamic control. Let's take a look at this on the next video.